Welcome to Binod Suman Academy on YouTube, and we are going to talk today Keras. Keras is a very best and easy way to start your coding development in deep learning and neural network. The easiest way to create the machine learning models in neural network is the Keras. So, during this video, I would explain how to install the Keras, what are the basic things in the Keras, and how to create one deep learning model end to end with the hands-on code. Let me start. So, what is the Keras? If you go to the Keras website, it says it allows easy and very fast prototype way to develop any deep learning model using the Keras. So, as I said, we will see how much easy it is. What is the Keras? As I said, this is the framework has been written in Python, and that is based on the TensorFlow and the Theano. Means Keras is the UI, and backend side is the TensorFlow or the Theano. It makes the easy life of developer to create the model in very easy way. It hide a lot of things from the TensorFlow and give you a very easy and sophisticated API to develop the neural network. So how the Keras it works? As you see, Keras is the front end and back end. Either you can keep Thino or you can keep the TensorFlow. In easy configuration, you can do interchange. Now the question is that what is the main difference between TensorFlow and the Keras? And this is the common question comes in any developer mind if they start first time deep learning or the neural network. So if you see the TensorFlow, you have to write more code because it directly connect to the internal row level functionality. So for each and everything, you have to write the more code. The same kind of functionality, the same kind of behavior you could achieve with less amount of code in the Keras. Of course, Keras is top up on the TensorFlow and we work through the API that has been built on TensorFlow. So we would not do all those things what we can do in TensorFlow, but most of work for the model development, image recognition, all kind of deep learning we could achieve through the Keras. So now how to how to install the Keras? It's easy. You have the two way. Either you can install Keras with the TensorFlow or the Keras independent. But for the both way, you should have the TensorFlow already installed, and we have to install the Keras on top of the TensorFlow. So as we know TensorFlow how to install, I have made already one video how to install the TensorFlow. So let me show that. So this is the Keras website, Keras.io, and this is my video on YouTube where I have explained how to install the TensorFlow and 2.0 and all the basic command I have given here. So you can do watch this video to get more about how to install the TensorFlow. And please don't forget to subscribe this channel. Let us come back. Now, what is the neural network? So neural network is the layer of neutrons or the neuron. This is the input layer, this is the hidden layer, and this is the output layer. So a neural network is a machine learning algorithm that made up of the individual nodes that is called the neuron. They connect to each other and the output of one layers become the input for the another layers, and we have to use the activation methods and all those things. So if you want to know more about that, I would recommend you visit my this video basic of TensorFlow and also the what is activation function in neural network, and here I have explained what is the neural network, how it works, how it is different from the human mind, and what is the neural network in detail I have explained in this video. Please I would recommend please go and watch this video. And each Each circle is called the neurons or the node, and each node calculation is that we have the input x1, x2, x3. For the each input, we have the individual weight w1, w2, w3, and for the each node, each neuron, we have the bias. So what we used to do, we multiply x1, w1, x2, w2, x3, w3, add, and then we have to add the bias, and bias go to the activation function. As I already explained, if you want to know more about activation function, I would recommend please visit my video on the neural network. And if you want to know how this calculation happen, how the multiplication happen between x1 and w1, then again I have made one video, so I would recommend you watch this video to I have explained all the mathematics behind a neural network, how it works. So it will give the very good insight how mathematics and the matrices are behind in the neural network. Okay, so as I already explained, this is the input layer and this is the hidden layer, this is the output layer, and this network is called the dense. Why this network is called the dense? Because output of each neuron is connected to all the neurons of the next layer. That's why it is called the fully connected network, or used to call the dense. Move to the next slide. Okay, so now the time has come. We have to um, create the model, and these are the different phase how to create the model. First you have to create the model, then you have to add the layers, hidden layers, input layer, output layers. We have to compile the model, we have to train the model, then you have to check the performance, and we can predict the new data with already developed the model. So let us proceed one by one. This is very important slide for this complete video. All the model we create in Keras. So first you have to call sequential method. It will create one placeholder model. And now you have to add the different layers in the model. How you will do that? I have explained for the first input layer. So input layer, if you see, we have the 1, 2, 3, 4. So we have the 4 input, right? So that's why I have given the input dimension is equal to 4. Next year, this 4 would be connect to the 5 neurons. 1, 2, 3, 4, 5. That's why I have written here 5. Activation function. Activation function decide which kind of output or trigger in the next layer. So that is called the activation function, and we have used the arrow. And depend upon your business requirement, we could choose anyone. How to add the output layer? You can see the output. It is also dense because all the input is connected this one neuron. So that's why this is the dense. Is only one node. I have given one, and activation function is sigmoid because this is the binary classification problem. Then it output either one or the zero. That's why I have used the activation. Activation is the sigmoid. This is also important slide. What we have to do here, suppose if you have developed this kind of model, Keras model, what you will do? Let us go one by one. The first is the input layer. So how many input layer we have? 1, 2, 3, 4. So I have given the 4 dimension. This is the input, yellow color. 1, 2, 3, 4. 4. And the first hidden layer has also the 4 node. So I have given the 4. Activation, I use the yellow. Now the second, this one, how many we have? 1, 2, 3, 4, 5. That's why I have given the 5. Next is the 6 neuron. I have given the 6. Next is 4. The next is 3. And output is 3. So I have given the output 3. As the output is more than 1, we could not use the sigmoid, so we have used the softmax. If you could watch my video on the activation function, you can get more about which activation function should use when. Now, if you think in this case, if you see we have the many number of layers and the neurons, how we can decide how many layers and neurons should be there. So there is no any predefined algorithm who can give you the answer for this. This is the heuristic way. You have to do the research, or you have to do the R&D. You have to come up with the different number of layers and the neurons, and you have to find out which model is giving the accurate answer to you, and depend upon that we have to develop the model. Next is the once you create the you add the layers. Now you have to compile the model. During the comparison, you have to pass three arguments: loss, optimizer, and matrix. Loss, we know that when you go for the forward propagation, then you have to measure the output with your expected result, with your calculated result, and you have to measure how much loss is there. And accordingly, you have to go the backward propagation, and you have to set the weight and the bias data. So we have the many kind of loss method. So we can use any one of them: mean squared error, squared log, log cost, binary. There are many things you have to choose. Second is the optimizer. Optimizer is also important factor here. So it optimizes the back propagation to twin the weight and the bias. How much weight you have to twin, how much bias you have to twin to get the approximate result. So this is the optimizer. We have many different kind of optimizer already established, already coded in the Keras. These are the AgaGuard, AgaDelta, Adam, AdamX. Most of time we use the Adam. And matrix is that how's the performance of the your model and which kind of matrix you want to generate. So we can define. We will see all those things in when we do the code for that. After the comparison, model comparison, we have to fit. We have to give the x and y. X is the input data set, except the Keras, the last target Keras column, and this is the target Keras y. And now we have the two important concept, epoch and the batch size. Try to understand what is the batch size. I have given the table here. Batch size means, suppose in your data set we have the 1000 record or 10,000 record. If you pass the 10,000 record all together in one shot in your in model calculation, it might be not work because it required a lot of resource, a lot of memory, good kind of system configuration would be there. So that's why it is recommended, don't give the complete input one shot, give the batch size 10, 20, 50, 100, depend upon your system configuration. So that is called the batch size. Epoch is that how many times you want to run this complete layers. So every time if you run, it will set the optimizer we work, it will set the weight and the bias to minimize the loss. So this is the time of how many times you want to execute, how many times you want to train the model. So if you can see here, number of epochs to train the model. And the shuffle, which kind of shuffling you want to note, verbose, you want to get any output or don't want, depend upon you can give the data. 1, 2, 3 is there. Then you have to evaluate, means how much score is there, what is the accuracy of the model, and then we have to predict with the new data. So let me put all together in one page. So first we have to get the data. In our code today, we will use the diabetes CSV. I will show you. First, create the model, add the layers, compile the model, fit the model, then evaluate the model, and we see the prediction how it works. Okay. So let us start the here. If you see, I have already the diabetes CSV file. What is this diabetes? Let me show you. This is the data, input data. So 7 columns, we have the different parameter to predict whether patient has diabetes or not. And this is the binary classification. If you see the binary classification, 0, 1 is there, right? So we are going to use this data. And if you have to install the TensorFlow, then you have to install Keras. So what you have to do, pipe install Keras. As I have already installed, so it will not install again. It will show that is already satisfied, so already installed. Okay. So then let me start the Jupyter Notebook. Yes. So Jupyter Notebook has started. Yeah. Let me bring this side. We create new one. You see in this folder, I have one on your CSV. So first, what you have to do, you have to take from import the models keras dot models import sequential. So you have to create the model sequential model as I explained you. Then you have to create the dense layer. So layers import dense. Okay. Then we have to use the NumPy to download our database dataset. So from NumPy as NP, perfect. NumPy, oh, I have to import. Then we have to download our data. So what I have to do, np dot load text, and you have to give the file name. File name is Pima. Yes, it is giving prompted. And you have to show the delimiter, which kind of delimiter. So it is a comma separated you give. And we store this data in any variable. Let me use the data set. Some any name you can give. Now it is important. Let me check how many data are there. So we have 768 row. Data is not very high, just for demo purpose I have taken. And 9 means all the 9 columns are there. 8 column is the data and 9th column is the target class. So we decide the binary classification. Okay. So let me divide. Let me take the first 8 column in the X and Y into the target class into the Y. So X I take data set. I have to take colon means all the row, but only till 8 column, and Y also take all the data set, all the row, and only 8th column. Okay, let me execute. Fine. Yeah, let me first see the first data is yes. So now you can see the first data is the same data 0, 148, 50 inside that. Yeah. And if we say the y it will show the one data only the last one. This is one. Okay. Now we will create the model. Interesting part start. So what we have to do, model is equal to sequential as I explained you, and take the add the first input. So what we have to take dense as we discuss, and we are going to take the 12th node in the next layer. After the input layer, next layer I'm taking the 12. This is assumption. There is no any tough rule that you have to take the 12. This is my assumption. I take the 12. If it will not work, I could change the number also. Then input dimension is the 8 because I know my data is the here 8 8 8 0 to 8 column is my data till 8. Then we have to use the which activation function you are going to use. So we are going to use activation function. This is the first one. We will use the value. Then we have to add the another layer. Again, this is the dense. And this time no need to input because this is not input. This is the hidden layer. So next I want to put the 8 because why I'm putting the 8 because 8 is coming from the input to the here, and then activation function I am going to use this 8 again. I'm taking the 8. This is not depend upon the input. So as I say for the next I get 12 then the 8. This is my assumption, and this also I'm going to use the value. And now I'm going to add the output layer. This is the demo, so I am not making any many more hidden there. So I know this is the binary classification. I take only one, and activation function I am going to take the sigmoid, as I know sigmoid is the binary classification. Sigmoid. Run that. Good. It runs perfectly. Now we have to, after creating the model, we have to compile model, right? How to compile model? Model dot compile is there. And I explain we have to pass the three things: loss, optimizer, and the matrix. Okay. So the mouse cursor. Yeah. So first I'm using the binary cross trophy. This is one kind of the loss method. Then you have to use the optimizer. Optimizer we use the Adam. If you give any wrong number, it will give the errors. And matrices we are going to use. You can use the many matrices, so it is taking the array accuracy. Run it. So now it's run. Okay. Now we create the model, compile the model. We have to fit the model, right? So we have to use model dot fit. And as we discussed, for the fit model, you have to pass the x, y, and the epoch, right? So let me put just 50 epoch for time being. And we have to use the batch size. So let me take the batch size 10. And then I want to see the output also, take that 2. Now, if I run, you can see that it will execute the 15 times. Sorry. So you can see it is one time, two time, three time. Every time it is showing the when it executes the first time, how much loss was there? 7.93. The number goes. Now we have 64% loss is there. So okay, let me increase the number. Then you can see. So how? Let me put the 150. Not here, here, and again execute. Now see, it's moving. 34, 23, 39. Yeah. Yes, I think executed. So now we improved. Now it is the 0.48% loss, and accuracy is the 76%. So let us keep those data up to here, and now we move the next part. We have to uh, check the accuracy. So how much accuracy is there? So evaluate our model. So how to do that? Model dot evaluate, and you have to pass the x and y, and capture this output in some variable. And we can see this, it executed for all the records, 768 records. We want to print what is the score, so we can print. Okay, let me just model dot matrix and score. I want to into the percentage, so let me 100. Let me see what is the output. What is saying? Out of range. Model underscore matrix. Okay, so this method is not correct. Yes. So now we can say that we have the accuracy 78%. So matrix name is the accuracy and the score is the 78%. Not bad because we don't have the use data and we have not checked all the number of players and the nodes. So it's just demo purpose why I made like this. Now if you want to prediction, how much, what is the prediction? So model dot prediction method is there, predict and pass the X. Just I want to see my data, just giving my input to check how it works actually. And obviously it should work good because on this data they have created the model. Prediction is right. And just doing the prediction, see what it happens. Oh, so we have to do the round then. So now you can see this is our prediction, and most of the prediction is the same with our input because input if you see 1010101011. So it is also 10101011 because I have given the just input. So yeah, let me back to here. So that's what all about the Keras. It's easy, and this is the way to create the model and a lot of things in the Keras. But it was the first video, so that is sufficient for first video. Thank you very much for watching. Please subscribe this video, and in my Vinod Suman Academy, I am putting every day new video on the data science. Please subscribe and be tuned with my YouTube channels. Thank you very much.